Hello and welcome to the second lesson of sequences and series. Previous lesson we looked at arithmetic sequences, which was just a listing of terms where each of those terms had a common difference between them. We were always going up by the same number or always going down by the same number. But we could always say that we were adding something to each term to get each next term. In this lesson, we're looking at a series, where a sequence is a listing of terms where we have commas in between, and we could say this is term 1, and then term 2, term 3, term 4, all the way up to whatever term that is. A series has plus signs in the middle. We're adding all the terms of the related sequence together. And that is the main defining difference between a sequence and a series. Now, in order for a series to be arithmetic, it has to be based on an arithmetic sequence. So this sequence right here, we know it's arithmetic because as we go from one term to the next, we seem to always be going up by 2s. And then those same terms, this 1, the 3, 5, 7, and so on, are all used in this series. Now, to refer to a particular sum or a sum of certain number of terms of a series, we use a big S. It looks like this. It's an S. And Sn, with whatever index we use for n, tells us how many, or is the sum of the first n terms. So where we had the sequence which started with 1, 3, 5, 7, S4 is the sum of those first 4 terms, the 1, the 3, the 5, the 7. S6 would be the sum of the first 6 terms, and S1 is the sum of the first 1 term. Now, we could compute these a bit manually, like use your calculator to say 1 plus 3 plus 5 plus 7 plus 9 plus 11, and gets you some number, which is all good and well. But there is also a formula that will be of use, and the development of this formula is based on a couple of things. It's based, first of all, on looking at the terms in this kind of form, where we notice, this is of course term 1. Over here, T1 plus D, that's T2. And if we add another difference to that, we get T3, so on and so forth. And at the very end, we have Tn. It is also worth noting that, depending on how many terms we want to show in this proof that's about to happen, the term right before this n term would have one fewer differences in it. So where this one has n minus 1d, and that's term n minus 1 would have n minus 2d's added to T1. So little things, well, pretty important things. They are small, but certainly extremely important. And those are going to get used in development of this formula. It starts by us saying that the sum of the first n terms is all the terms from term 1 to term n being added together. So down here, awkwardly spaced out for who knows what reason, but actually for a legit reason, we have these terms. So there's term 1, and there's term 2, and then we hit the old ellipsis, the dot, dot, dot in the middle. It says keep going and going until we hit these other 2 terms. The last one is term n. It has that form T1 plus n minus 1 times d. So that's the nth term. And then right before that, we have term n minus 1. So the term immediately before that. So this essentially says take all the terms from the very first one to the nth one and add them all together. To develop the formula, we're going to rewrite this. Sn equals. But in the rewriting, we're going to flip the order. So we'll have whatever's in green, we'll have whatever's in yellow, we'll have the orange part, and we'll have the red part. I don't know if I spaced them out enough. I guess we'll find out. So this green piece over here, that's going to go over there. and that is the nth term, t1 plus n minus 1 d. And then we add to it the term that would be right before it, so term n minus 1, and that's this here underlined in yellow, t1 plus n minus 2 d. And we keep going, the so on, so forth. And then underlined in orange here was t1 plus d, so we'll put that in there. And then underlined here in red was t1 itself. So these represent the same thing, just in a different order. It's like having 1 plus 3 plus 5 plus 9, but 9 plus, wait, I skipped numbers. 1 plus 3 plus 5 plus 7 plus 9, but the other order, 9 plus 7 plus 5 plus 3 plus 1. It gives you the same result no matter which way you add them together. Your next step is going to involve some addition. I can draw a straighter line than that. There we go. On this left side, we have Sn plus Sn. And that gives us 2 Sn. On this right side, we're going to column by column add these terms together. So we've got these two being added. T1 plus n minus 1 times d means that these two T1s will give us, oops, that's small, 2T1, and then we'll still have this n minus 1 times d. And then we'll go to the second column. That's these getting added together. And once again, we have T1 plus T1, so that'll give us 2T1. And then we have D plus n minus 2 times D. So we had n minus 2 of these differences, and then we added one more difference. Now, that is n minus 1 of those differences. Well, that's kind of interesting. Well, probably meaningless. We'll move on. We've got these ... so as process continues, we get the last bunch, which is just like the sum we just took, right? It's just the flipped version of this particular sum. Now this orange is on the bottom, and now this yellow underlined part's on the top. It gives us the same sum overall, which is, once again, 2T1 plus n minus 1 d. And then finally, at the very end, adding these two columns together. That's just like our very first one, and that is, again, 2T1 plus n minus 1 d. And what do you know? All of these are the same. There's a nice light purple I can use to underline these. We've got 2T1 plus n minus 1d. We've got 2T1 plus n minus 1d. We've got 2T1 plus n minus 1d. We've got 2T1 plus n minus 1d, with like a whole bunch more in the middle. Who knows what n is? A great question would be, how many of these are there? Well, remember, this is the first term, this was the second term, and then ... This was the second last term, and this is the last term, the last term's index being n. So there are n of these. Whatever n is, that's how many we have of this repeating little expression. So we can more succinctly say that 2Sn is equal to n of all of these repeating expressions. 2T1 plus n minus 1 times d. finally, we wanted just a formula for Sn itself. And we can just say, well, we've got 2Sn. So we're just going to divide both sides by 2. You don't have to write that you're dividing by 2. Remember, you just have to actually do it. So Sn is n over 2 times all that stuff in the brackets. I'm not sure how many of you have seen the use of these square brackets before. They can be handy just from an organizational standpoint. They mean the same thing as the rounded brackets here in terms of an order of operations notation, but they help with just the grouping so you can see what bracket starts, what a bracket ends. You don't have to use them. You could just as well do this with round brackets instead. But I personally prefer having the square ones once I start nesting layers. Anyhow, that's excuse me. That is the development of this formula. And this formula can be used to find the sum of a sequence, or the first n terms of a sequence, as long as we know what n is and what the first term is. Oh, I missed the difference. D. Nailed it. Okay, so that's just to highlight that in case you missed what I forgot. This right here. I forgot to put the difference in there. It carries down from the line above. Make sure that's in there in yours as well. But this formula, as long as we have n, t1, and d, we can find the sum of the first n terms. We can find that related series. There is another formula that exists, and it's developed straight up based on this one we currently have. And it's using the idea that, hey, part of this looks kind of familiar. In fact, if we look at the previous lesson, way back in the day, we had this. Tn is t1 plus n minus 1 times d. And that's kind of like what we have here. It's just we've got 2 of these t1s. So for the development of the other version of the formula, we start with Sn as we just developed it to be. S sub n is n over 2 times 2t1 plus n minus 1 d. So it starts with that that formula we just attained. And then we'll break up the 2 t1s into a t1 and another t1. And then we'll still have this n minus 1d thing at the end. Neat. So, in this final line, let's give ourselves some space, why not? We'll note we have t1. Let's put that in there. And then we have this, which, as we just noted a moment ago, is the same thing as Tn. That's the nth term. Term 1 plus n minus 1 differences gets us term n. Once again, you can use the round brackets here if you want, or you can use these square brackets too. Whatever you kind of prefer there. I just use the square brackets in this last line because even though there is no more nesting, it's still the bracket I was using for that particular spot this whole way down. So from a consistency standpoint, I went with those square brackets. That also works. Again, notation-wise, they mean the exact same thing in this context. This formula does not require us to actually know what the difference is. It does require us to know n, term 1, and what that nth term is. Like what term are we ending on? What's its value? So, for example, like in this particular series at the beginning, we had 1 plus 3 plus 5 plus 7 plus so on and so forth, and then 23. We don't know what n is, but we do know that Tn is 23. And we could do a whole bunch of manipulation to figure things out. We could find what n is. We could find what d is if we want, and then really be able to use any formula we want. But it's kind of a game of trying to figure out what we have, what we're missing, and then what to plug into. You can plug into this formula that we developed on page 106, or you can plug into this formula that we've got here. But again, depending on what we know. So we're going to try some examples. And it's going to be overall pretty wicked. But again, figuring out what we know. You can organize your information for yourself on the side or on a scrap paper or wherever it goes. Here, I'm noticing we want the first 20 terms. So we know that n is 20. And we know that we also want Sn, right? That's what we're trying to find, the sum of the first 20 terms. That's S, actually I should be more specific, that's S20 is equal to something. No idea what it is yet, but we'll find it. It'll be wicked. Other things we know term 1 is equal to negative 12. I don't know what the 20th term is, so I can't directly use the formula we have just above these examples, because I need that nth term. But I could pretty easily find the difference. And that one would actually have to be shown. The difference is negative 10 minus negative 12. Remember, taking any term and subtracting the term before it. And that tells us that the difference is positive 2. And we can see that evidenced here. To go from one term to the next, we keep adding 2. So it's backed up by what we see. So let's plug into a formula. The formula, again, can't use this one here because we don't know what Tn is. And sure, we could find it, but not worth the work. We're going to use this one over here. And that was an eraser. This one over here. With enough repetition, you might memorize it, but it will get provided, so don't feel the need to. So Sn is n over 2 times 2t1 plus n minus 1 times d. So the thing we're trying to find is S20. N is 20. T1 was negative 12. Putting 20 in for n again, and then the difference was 2. That is 2 marks right there. One for establishing difference, one for substituting into an appropriate formula. And that's 2 out of 2 with an E1 simplification error just because this has to be evaluated. You can do it manually, like doing the step-by-step process, following order of operations, all that jazz, or plug it into your calculator and see what you get. And you should, if you type it all correctly, you should be getting 140. So that is how to use the, the formula here. Take a moment, try the next few examples. Examples B and C will be very similar to what we just did. Examples D and E might be slightly different. We'll see how. But give them a try, and even with examples D and E, see how far you can go. But take a moment, pause the video, give them all a fair try, real honest effort, and then resume the video in, I don't know, it's a good solid, maybe like 10 minutes. That should give you some time with all of them, and that'll be that. Alrighty, I'm assuming you paused the video at some point. If you didn't, whoops. Well, I'm going to keep going. So, looking at this next example, I say so a lot. Showing Toastmasters again, stamp that out. Anyways, stuff I know. N is 101, and I want to find the sum of the first 101 terms. And if I try that manually and I go -1, plus negative 2 plus negative 3 plus is going to take me forever. So that's where this formula is pretty heckin' useful. Other things we know. We know term 1 is negative 1. And the difference we don't have. I mean, we could probably see it. Looks like we're going down by 1 every time. But we do need to show that. The difference is any term minus the term before it. Negative 2 minus negative 1 is negative 1. And if you don't believe me, use your calculator. Because once again, this is a calculator unit. Just like the previous example, Sn is n over 2 times 2t1 plus n minus 1d. And we can substitute into that. N is 101. Term 1 was negative 1. And d was negative 1 as well. Oh, my little oopsie here. I shouldn't have written Sn there. So in the last example, I wrote S20 because at that point we were specifically finding the sum of the first 20 terms. Same here. This shouldn't be Sn. That should specifically be S101. Right? If we made all these substitutions, then we should be making that substitution as well. They all have to happen at the same time. Otherwise, it's kind of a lapse in the communication. Anyways, this point, calculator. And according to my calculator, excuse me. According to my calculator, this is negative 5151. So negative 5,151 as that result. That is DUN done. Sorry, leave it there for a second while I take a sip of this Wawa. Alrighty, on to the next example? Sure. And again, this one works just like the other ones. So pretty much the same. We're going up to term 13. So we know for sure n is 13, and we want to find S13. Right? That's what we're after here. We know term 1 is negative 8. We can find the difference, which is negative 5 minus negative 8, so 3. And again, that formula Sn equals n over 2 times 2t1 plus n minus 1 times d. And just subbing stuff in. Oops, I did it again. I wrote Sn. We're specifically after S13. And that is going to give us 13 over 2 times 2t1. T1 was negative 8. Just one other thing, super minor and rare that it happens. Sometimes I mistake my own writing, and I'm a little worried that I'm just gonna think this bracket is a 1. That does happen with some of you sometimes, so you might want to just make sure everything you write is written such a way that even though you know it while you're doing it in that problem, if you go back and check your work, you're not kind of confusing yourself, or even if you go a couple steps later. It's happened before. It's unfortunate when it does. So just try to mitigate that is all. Anyways, no, not D. We know what D is. D was 3. Nailed it. And jumping to calculator, S13 is 130. Now, as I indicated, the next two examples are a little bit different. But still same idea of like figuring out what we know and what we can do from there. Here we've got some information, right? We know what term 1 is. Term 1 is 1. Okay. We can find the difference. And that's 3 minus 1. So the difference is 2. We don't have n. We know that we end on 33. But I don't know, is that term 47? Is that term 100? Is that term 9? It's impossible to tell, except that it is possible to tell. We're going to figure it out. But we absolutely need that value of n. If we don't have it, we can't use either of the formulas. This formula relies on n right there, and this formula relies on n right there. So that's absolutely needed. But we can find it because we know that Tn is T1 plus n minus 1 times d. So this 33 is the same thing as 1 plus n minus 1 times 2. And we can just figure out n from there. So subtracting 1 from both sides gets us there. Dividing both sides by 2, and then adding 1 to both sides. So n is 17. Now we know. So subbing into formula. I'm not going to use, the most efficient one, I could use pretty much any of them now. But the most efficient one for me to use right here is this one. And that's because there's way fewer pieces in this whole puzzle. So S17, now that we know that's what we're getting, is 17 over 2 times term 1 plus term n. And as you can see, like that's much less involved than a formula like the one we had above. Lots of components in there. This one, very few. And when we compute that, we get 289. And that one's done. So one more example, and that'll be that. If you haven't given it a try, I know we had those 10 minutes before, but if you haven't given it a try yet, give it a try now. Now that you've seen example D, it's going to work just like that one. So again, give it a try, pause the video, a few minutes, and then resume video, see where it's at if you need to. All right, I'm assuming you've paused. And then, well, I assume you resumed anyways. Your video's playing right now. That stuff we know. I know term 1 is 9. N, I have no idea. D, the difference is 4 minus 9, so the difference is negative 5. And then we don't know n. We do know that the last term is negative 26. So using that business, that Tn is T1 plus n minus 1 d, we'll say negative 26 is 9 plus n minus 1 times that difference of negative 5. Alrighty. Be careful with your mathematical operations here. There's a lot of integers flying around, and it can be really easy to make oopsie poops mistakes. You can confirm things with calculator. Calculator might be a little less efficient, but it depends if you're getting correct answers out of your head brain or not. So when you take negative 26 and subtract 9, you're not going to negative 17, even though negative 26 and negative 17 are 9 apart. Just remember the directionality of integer subtraction. Negative 26 minus 9 is negative 35. And that gives us negative 5n minus 1. Dividing both sides by negative 5. 7 is the same thing as n minus 1. And adding 1 to both sides, we get that n is 8. Now we have all the pieces of the puzzle. We can put them all together. And using whichever formula, but this one's going to be the easiest one to sub into. We know specifically we're after S8, and that'll be 8 over 2 times T1 plus Tn. And that'll give us a result. Punching that into calculator, I get negative 68. And that is DUN done. And that's arithmetic series. All in all, pretty cool stuff. Work on the practice work. Give it a go. Note if there are any errors where you find any difficulty. And see what you can do. A lot of formula plugging in, a lot of picking apart what information we have, what we don't have, and all that. But give it a go, and we'll see what happens with that. It's been a slice. I hope you've enjoyed this video lesson, or at least tolerated it. Sorry that they've all been video lessons and they're kind of dry. It's limited options. Anyways, take care. I will see you soon. Tell everyone I say hello. Boop.